question, a recurrence relation is given. T of n is equal to 1 if n is equal to 1, and T of n is equal to 2 into T of n by 2 plus root n if n is greater than or equal to 2. So here we have to express T of n in terms of asymptotic notations. So for this kind of problems we use Master's theorem for solving. So let us take case 1 of Master's theorem. If there is a if there exists constant epsilon greater than 0 such that f of n is order of n power log a to the base b minus epsilon. So where f of n is, T of n is nothing but a into T of n by b plus f of n. So here we can say f of n is equal to root n, a is equal to b is equal to 2. So let us check this condition. So f of n is nothing but root n is order of n power log 2 to the base 2 minus epsilon. So root n is order of n power log 2 to the base 2 1 minus epsilon, and here epsilon should be greater than 0. So let us take 0.1. Epsilon is equal to 0.1. So 0.1 is greater than 0. So let us take 0.1. If we take 0.1, 1 minus 0.1, n power 0.9. So here n power 1 by 2, nothing but 0.5 is order of n power 0.9. So which is true. So that means it satisfies case 1 of Master's theorem. So in that case, that is, if f of n is order of n power, if f of n is order of n power log a to the base b epsilon minus epsilon, where epsilon is greater than 0, then T of n is theta of n power log a to the base b. That means here T of n is theta of n power log 2 to the base 2, so which is theta of 1. So here you can say option B is the correct option. Which is not an in-place sorting algorithm? A. Bubble sort, B. Mid sort, C. Insertion sort, D. Heap sort. In order to solve this problem, first of all we need to know what is an in-place sorting algorithm. An in-place sorting algorithm is one whose additional space requirement is order of 1. That means in in-place sorting in-place sorting algorithm, elements are sorted within the same array. No extra space is required. If we see all the options here, option B, medsort, is not an in-place sorting techniques. Why? Because it requires one complete additional array called auxiliary array while sorting the elements. So here medsort is not an in-place sorting algorithm. So your correct option is option B.
Match the following list. Here we are having two lists, list 1 and list 2. List A contains a working set model, B dual mode operation, C wait for graph, D lazy swapper. In the list 2 we have 1 deadlock, 2 virtual memory, 3 thrashing and 4 protection. So here working set model is a model which we use for limiting the thrashing. We are going to select some of the pages in working set, and whenever those pages are changed, then we will change the working set and the corresponding pages will be there in the memory in order to reduce the page faults. Because the thrashing is high paging activity, in order to reduce the page fault rate, we have to go with working set model based on the locality of reference. So A is related to 3. Working set model is for limiting the thrashing. Dual mode operation. We can operate the computer system in two modes. One is a system mode, the other is user mode. In order to protect the code and data of operating system from the user programs. At the same time, user programs and data must be protected from the operating system code. That is why we will operate the system in two modes. One is the system mode or supervisor mode, and the other is the user mode. So the dual mode operation is related to protection. So B is related to 4. Next, wait for graph. Wait for graph is which we use for detecting the deadlocks when each resource type containing single instance. It will be used for deadlock detection. So it is related to deadlocks. There in a wait for graph, we used to show only the process by removing the resources when each resource is containing single instance. And the lazy swapper is nothing but a pager which we use for the transfer of pages from disk to primary memory while you are implementing the virtual memory, because in the virtual memory implementation we have to go with demand paging. Demand paging is the implementation technique. For implementation of demand paging we use the lazy swapper. Sometimes it is called as pager also. So that lazy swapper is related to virtual memory. So D is related to 2. So A3, B4 and C1, D2. So option B is the right option here. There were 25 bits in a physical address. The physical memory is divided into 32 equal partitions. If the total number of entries in the page table is 2 power 22, then what is the total number of bits in the logical address? So here we need to find out total number of bits in the logical address. So what is the size of logical address? We don't know. That we have to find out. What is the size of physical address? That is given. That is 25 bits. Normally in a paging we are going to divide the physical address into two parts, that is the frame number and displacement, and the logical address into two parts, that is the page number and the displacement. The physical memory is divided into 32 equal partitions. That means those are called frames. How many bits are required to identify one frame among 32 frames? 5 bits are required, because 2 power 5 is 32. So 5 bits. Out of these 25, 5 bits are used for frame number. What is the remaining bits? 25 minus 5. So 20. Normally the displacement of a frame is equal to displacement of a page. That is why here also we will get 20 bits as a displacement. So actually the number of pages, the small hint is given in the problem, that is the number of entries in the page table is 2 power 22. Actually the number of entries of page table is equal to the number of pages available. So if there are 2 power 22 number of entries in a page table, definitely 2 power 22 pages are available. To identify one page among these 2 power 22 pages, we require to have 22 bits. So 22 bits are for page number, 20 bits as it is displacement. So here the data given for the physical memory is useful for knowing the displacement. The data given for the page table is useful to know the number of bits for the page number. So 22 plus 20, total 42 bits are required in a logical address. That means logical address contains 42 bits. So option A is the right option here. Option A is the right option here.